Hello and welcome to our math lesson for today. Today we're going to be doing lesson 13-1, 2, and 3. And all these are going to be focused on solving inequalities. Now, you may be saying, Mr. Barry, it's a lot of stuff to go over. We're going over 3 lessons today, 2 the next day, and then we're reviewing and taking a test all in a short week. Yes, it sounds crazy, but I will go ahead and tell you this is all just the same thing with one small change. And that's what you're going to see today when we start to go ahead and solve our inequalities. So hang with me until we get there, and then you'll realize, oh, this is not so bad. So for our anticipatory set today, I'm going to go ahead and talk about something I learned as a kid, and you may have learned it too. So here we go. Here's little Mr. Barry. All right, so there's little Mr. Barry. He's in some young grade. And here is my teacher. And my teacher said, hey, when we start to talk about greater than or less than, this is what you should imagine. So this is a sign, and just pretend that it is a crocodile with some teeth, and the crocodile likes to eat the bigger number. Right? That's what I was told as a kid. And as a kid, I go, oh, okay, I guess that makes sense. Sure, the crocodile wants to eat the bigger number. But then I realized a little later on in my life, now that I'm older, here's Mr. Barry, that it would have been a whole lot easier and saved me a lot of confusion if at some point someone had just told me what that really meant. All it is an equal sign. It's the same thing as an equal sign. It's just we're pinching it a little bit. So it's like that. Same thing if we go the other way. Just pinch it a little bit. So it's like that. If someone had explained that to me as a kid, when I got to a certain point when I saw, let's say, I know that 2 plus 2 equals 4. I knew that from a very, very young age. But then when I saw 2 plus 2 is less than 5, I was a little bit more confused. And I was saying, okay, well, the little monster is trying to eat the bigger number, so it must be. If I had just realized it's the same thing as a equal sign, this is the same thing as an equation. We're just pinching that equal sign a little bit to make it look a little different. I would have felt a whole lot better about things. So you may have already known that. I'm sure you did. But I might as well use that as our anticipatory set today before moving on. I'll zoom in a little bit. Oh, might be a little too much. Fix this just a little bit. How is that? Yes. Perfect. Okay. So let's go ahead and get into our standards. And as you know, we've gotten to the point now where our standards, there's a lot of standards. We see a lot of these standards, and they're all being used for the same lesson. But today, we're just going to focus on one. So a lot of these ones are always going to be the same. But the one we want to focus on today is going to be 7.EE.4. 7.EE.4. And what this states is that we're going to use variables to represent quantities in real world or mathematical problems and construct simple equations and inequalities to solve problems by reasoning about the quantities. Okay, so that's our one standard. Now we have used this standard before. We've seen it before in some of our work, but we are going to focus today on these inequalities. So we're going to represent quantities in real world or mathematical problems. That just means either a word problem or just asking you a question. And then we're going to construct simple equations and inequalities. Now we've done equations. We are going to focus on inequalities today. And that's why you see we can do these 3 lessons at a time, because it's the same thing with just a few changes. Instead of equations, we're doing inequalities. But we're doing the same thing. We're solving these problems. We know how to solve these problems. We just need to know how to do them with inequalities. So let's go ahead and get into our input. Now, our input's going to be a little heavy on the heavier side today because we have several languages of the discipline I want to go ahead and get us putting down. In our language of the discipline today, they're just going to be these properties. We're going to have a lot of properties that we're going to be talking about. Okay? So we're going to write down, there's going to be, I'll even tell you right now, 1, 2, 3, 4, 5. We're going to write down 6 different properties. But you're going to see as we start to write them down that they make perfect sense. So the first one we're going to do is the addition property of inequality. Of inequality. Now, seems big and fancy, but what it says is very basic. The addition property of inequality states if you add the same number to each side of an inequality, the relationship between the 2 sides stays the same. That's all it states. Same thing as an equality. Right? If we're looking at an equation and you add a number to one side and you add a number to the other side, you know that it's still going to be equal. Same thing with an inequality. If you add the same number to each side of an inequality, the 2 sides stay the same. That relationship will stay the same. So let's take a look at a very basic example of this. If we simply know, everyone should know that 2 is less than 5. Everyone knows that. Kindergartners know that 2 is less than 5. Now, let's go ahead and test this. If we add the same number to both sides, so let's add 2. 2 plus 2, is it still less than 5 plus 2? And I'm going to go ahead and write out just a little tiny number line down here. Here's going to be 0, meaning this is going to be 2, 3, 4, 5, and this is going to be 5. Now, these are our 2 values. You can see that 2 is closer to 0 than 5, so 2 is less than 5. 2 is further to the left than 5. And now let's go ahead and see what happens if we add 2. 1, 2. This is now our value. 5 plus 2, 1, 2. This is now 7. 4 is still further to the left than 7, and it's still less than. So you can see that when we add the same number to both sides, the relationship stays the same. And this is true not only for what I've done here, which is less than, but less than and equal to, greater than and equal to. It'll be the same in with any of those signs. Okay, so that's all it's saying. And we're going to be writing a lot of these down, but really most of these are going to be the same as you see when we are doing our equalities, when we're doing an equation. Okay, there we go. So now let's go ahead and move on. I'm going to focus this one more time in case that was a little off. Perfect. Okay, Now I'm going to go ahead and move to the next one, which is going to be very similar. And the next one is the subtraction property of inequality. And I'm sure you can probably guess what this one's going to say. If we did our addition property of inequality and we see that it's the same thing, the subtraction property of inequality is going to state if you subtract the same number from each side of an inequality, the relationship between the two sides does not change. So once again, it's the same as we see when it's an equality. If it's an equation and you subtract the same number from both sides, it's still going to be equal. In this case, if you subtract the same number from each side, the relationship's going to be the same. So let's do another quick, very simple example. I'm going to use my same numbers from our first one, which is 2 is less than 5. We all know that that's true. 2 is less than 5. We all know that. Now, let's go ahead and say 2 minus 3. Is it still less than 5 minus 3? Well, let's take a quick look on a very basic number line. Okay, so here's 0, here's 2, 3, 4, and here is 5. Those are our values. As you can see, 2 is further to the left than 5, meaning 2 is less than 5. If we subtract 3 from 2, that's going to bring us to 1, 0, negative 1. Our new value is negative 1. 5 minus 3 is going to be 1, 2, 3. Oh, 5 minus 3 is going to give us 2. But still, the relationship is the same. Negative 1 is still less than 2, meaning that 2 minus 3 is still less than 5 minus 3. And this is true not only for what I did here, which was less than, but also less than, equal to, greater than, equal to. Any of those signs, this is also true. So those are the basic, easy, simple ones. Let's get into the ones where there's actually going to be a change. Now our next property is the multiplication property of inequality. And now we have to specify whether it's going to be multiplying by a positive or a negative. We are going to be multiplying by a positive, and you'll see that that makes a huge difference. This is the only thing that's going to be different about what we're doing today from what we're doing yesterday or last week about equations, and you've done in years past with equations. This is going to be the only difference. So when it comes to the multiplication property of inequality using a positive number, nothing changes. If you multiply each side of an inequality by the same positive, and make sure that you underline or notate somehow that we're talking about a positive, by the same positive number, the relationship between the two sides does not change. Okay, so if it's positive, it does not change. And again, let's prove this with some math right here. We all know, I'm going to go ahead and change my example a little bit, but I'm just going to say 2 is less than 6. We'll do that. 2 is less than 6. We all know that. 2 is a smaller number than 6. Now, let's go ahead and check if we multiply the same positive number. So we're going to say 2 times the same positive number on either side. Let's say 2 times 2. Is it still less than 6 times 2? Now, you can probably understand what is what right here because of us knowing what we're talking about and us knowing a little bit of math. But let's say here's 0, here's 2, 3, 4, 5, 6, here's 6. Okay? We multiplied by the same positive number. So let's see. 2 times 2 is going to be double what 2 is, right? So 2 times is going to give us 4. How about 6 2 times? We're going to multiply 6 by 2. That's going to give us 12. So 7, 8, 9, 10, 11, 12. Here are our two numbers. Now, the distance between them has definitely changed, but the relationship has not. 4 is still smaller than 12. So this side is still smaller than this side. And this works not only for less than, but also less than or equal to, greater than, and greater than equal to. It works for all of those signs, okay? So this was 2 doubling to 4 and 6 doubling to 12. Okay, so again, nothing has changed, still the exact same thing. I'm gonna go ahead and move to a new page where we can get our last couple properties written down. Now, the next one is going to be our division property of inequality. Division property of inequality. And again, we want to specify. We are talking about positive numbers. And again, that is very important, the fact that we are talking about positive numbers. Okay, if we're dividing by positive numbers, let's see what happens. If you divide each side of an inequality by the same positive number, the relationship between the two sides does not change. So again, nothing's different. At this point, you may be saying, Mr. Barry, there's nothing new. I know, but there will be. So hang in there. Okay, and once again, let's go ahead and test this. All right, 2 is less than 6. We all know that. We all understand that. So let's see if 2 divided by 2 is still less than 6 divided by 2. And let's go ahead and make our little number line. Here's 0, here's 2, 3, 4, 5, and here's 6. Now, we have divided by the same whole number on each side. So let's see if the relationship is in fact the same. 2 divided by 2, 2 split into 2 parts, is going to give us 1. Okay, 6 divided by 2 is going to split 6 into 2 parts and is going to instead give us 3. Now you can see the distance between the 2 points has changed, but the relationship is still the same. 1 is still less than 3. So this side is still less than this side. And as I've said before, this will be the same for less than and equal to, greater than and equal to. It'll work the same for all of those signs. Now, so far, you've been hanging with me. You've been seeing, oh, these are all the exact same as equations. Now, let's get crazy. Let's get crazy. All right, there we go. That's crazy enough. Okay, let's see the difference and see just how different things are going to be. Now, we have to go back to a property we've already written, which is the multiplication property of inequality. But this time, we're going to multiply by a negative number. Okay? So before, when we wrote this, we multiplied by a positive number. Now we're going to multiply by a negative number. We're going to take a look and see what that looks like. Okay? So the multiplication property of inequality with a negative number. And it states, if you multiply each side of an inequality by the same negative number, you must reverse the direction of the inequality. Now look very carefully at that. If you're multiplying the same negative number to each side, everything stays the same. The only thing that happens is you reverse the direction of the inequality. The relationship has changed. So let's take a look once again with our math and see how this in fact works. So we're going to have 2 is less than 6. Then over here, we are going to multiply by a negative number. Let's say negative 2. Is it still going to be less than 6 times negative 2? Let's get our number line out. We have, let's go ahead and put 0. We'll put 0 here. And then we have 2 here, and we have 3, 4, 5, 6 here. Well, let's look. What happens when we multiply 2 by negative 2? Well, it's 2 times 2, but we use the negative sign, meaning this 2 is going to become a negative 4. So negative 1, negative 2, negative 3, negative 4. Now, what about 6? 6 times negative 2 is 6 times 2 with a negative sign. 6 times 2 is 12. It's going to be negative 12. 5, 6, 7, 8, 9, 10, 11. Oh, no, 12. 6 is going to become negative 12. Now, if you can see, the relationship has changed. 2 is less than 6 here. However, 4 is now greater than negative 12. It's on the opposite side. The relationship has changed. So what we need to do, this is incorrect. 2 times negative 2 is actually now going to be greater than 6 times negative 2. You can see that we have swapped, we have flipped this sign. We have flipped that sign. Okay? And this works the same for less than, equal to, greater than, equal to. Okay, now that is a little crazy. So let's see if we can figure out what happens with our next and our last property, which is going to be the division property of inequality. And before, we used a positive number, so now we need to say with a negative number. Now you can probably guess what this is going to say, but I'm going to write it anyway. If you divide each side by the same negative number, you must reverse the direction of the inequality. Once again, if you divide by a negative number, you need to reverse the direction of the inequality. So let's take a look and prove it. 2 is less than 6. That is a fact. We know that. Now, how about we divide 2 divided by negative 2? Is it still going to be less than, I'll put a little question mark above, 6 divided by negative 2? We did the same number, but let's again check on our number line. I'm going to go ahead and put 0 here, 2 is here, 3, 4, 5, 6 is here. 3, 4, this is 5. Forget about this. This is 6. Okay. Now, if we divide 2 by negative 2, this is going to give us negative 1. What if we divide 6 by negative 2? It's going to give us negative 3. And as you can see, again, the relationship has changed. Now, this negative 1 is greater than the negative 3. So this is incorrect. The way it should actually be written is 2 divided by negative 2 is actually greater than 6 divided by negative 2. And once again, all we've done is we've flipped this sign. And this happens for less than equal to, greater than equal to. Okay, we've gone through every single one of our properties. Now, let's go ahead and take a look at a nice way we can remember this. So, now the process is the same as when we solve equations. So once you put these properties into practice, you realize everything is now the same, and your mind is then blown. There we go, get some smoke coming off. Boom. Because everything is going to be the same now. All you need to do is make sure you flip the inequality in 2 cases. And I'm going to go ahead and put a little cheat sheet down here for you. Let's say you are adding a positive number. You are adding a positive number. What happens? Everything's the same. Simple, simple, simple. Everything's the same. What if you are adding a negative number? Everything's the same. Nice and easy. What if you are subtracting a positive number? So remember, you can do that. Subtracted, it's the same thing as subtracting a number. But if you are subtracting a positive number, it's the same. If you are subtracting a negative number, it's the same. Now let's get into the tricky stuff. If you are multiplying by a positive number, it's the same. But if you are multiplying by a negative number, you reverse. Nothing else, just reverse. What if you are dividing by a positive number? It's the same. But what if you are dividing by a negative number? You reverse. And that's it. The reason why this topic is going to go by so quick, here we go, that's it. The reason this topic is going to go by so quick is because this is the only change. This topic is teaching us to solve inequalities. The only difference between equalities and inequalities is this rule. That's it. So let's go ahead and put this into some practice. I'm going to go ahead and get myself a new and final piece of paper. And we're going to do just a little bit of modeling so we can take a look at how this happens. All right. The same things we're going to need to do. We're going to need to solve two-step equations. We're going to need to do all that crazy stuff. But there's only one thing different. This is like the exact same thing we were doing last week. So, modeling. And we're going to worry about two-step inequalities. So we know the only rule that changes. So I'm going to do the same equation. I'm going to do the same setup twice. One as an equation, one as an inequality. And we're going to take a look and see the difference. Okay? So over here on this side, I'm going to go ahead and say x over negative 3 plus 12 equals 27. Okay? Simple, easy. We've done this before. It's a two-step equation. So the first step we have to do is we have to subtract 12 and subtract 12, right? Because that means we're keeping everything the same. Now our new equation is x over negative 3 equals 27 minus 12 is going to be 15. And then what we do is we multiply this side by a negative 3, since negative 3 would be negative 3 over 1. And we multiply this side by the same, negative 3. It was a division problem. But now look at this. We are multiplying by negative 3. Multiplying by a negative. Multiplying by a negative. We would reverse the sign. But look at the sign. It's an equal sign. If you reverse it, it's the same thing. So equals, we reverse it, it still equals. So when we do an equation, it never looks different. So we just know that x will equal negative 45. The sign could very well be flipped, but it doesn't matter because it's an equal sign. And that's our answer. Simple, simple, simple. Now, let's flip it over and take a look at if this had been an inequality. Same thing, x over negative 3 plus 12 is less than 27. Okay, so let's take a look at what we would do. Well, first steps first, we always need to subtract first, right? Or order of operations, we know what we need to do first, and it's subtraction. So if we subtract the same number from both sides, if we subtract the same number from both sides, we are subtracting a positive number. We are subtracting a positive number. It's the same. We are going by the subtraction property of inequality. If you subtract the same number from each side of an inequality, the relationship does not change. So the relationship is going to be the same. And our new equation is going to be x over negative 3 is less than, because the relationship does not change, 15. Okay. Now we do our next thing, which is we need to get rid of this division. So we need to multiply by a negative number. And we multiply by a negative number. Well, let's take a look. We are multiplying by a negative number. We reverse. We are going by the multiplication property of inequality. We are multiplying by a negative number. If you multiply each side of an inequality by the same negative number, you must reverse the direction of the inequality, meaning this inequality is going to swap. Over here, I'm going to go ahead and write reverse. So we do the same thing where negative 3 and negative 3 will cancel out over here, leaving us with x over 1, which gives us x. X, we switch the inequality because we're multiplying by a negative number to greater than. As you can see, we just swapped it. 15 times negative 3 is negative 45. So x is greater than negative 45. And that's it. That's the only difference between what we did last week and what we're doing this week. To remember that if we multiply or divide by a negative number, the sign swaps. The sign reverses. Now, how do we write this answer? How do we write this answer? On a number line, remember, we need to be able to graph this. So looking at this, it says x is greater than negative 45. A solution is not negative 45. It does not include negative 45. So let's say right here is negative 45. This is negative 46. This is negative 47. This is negative 44. A solution would be everything greater than negative 45. So here's negative 45. It's not equal, so it does not include, meaning we would need an empty circle, meaning we are not including negative 45, but everything else, and we are going greater than. 0 is this direction, so we go greater than. And that's how we graph it. Now, there's a few things we want to check. We need to check to make sure it is correct, and we need to check to make sure it is the correct direction. Two things. So the first thing we're going to do is we're going to check it, use a related equation. And what that means is you're going to use the same numbers with an equal sign. Right? Like we did up here. This is a related equation. It's the same numbers with an equal sign. So we check to make sure that we are correct. Now, we found that it was negative 45, so we need to fill in negative 45. So we have negative 45 over negative 3 plus 12 equals 27. And we just make sure that this is correct because we swapped out the less than sign for an equal sign. So negative 45 divided by negative 3 is going to be a positive number because a negative divided by a negative is a positive. 45 divided by 3 is going to give us 15. So our new equation is 15 plus 12 equals 27. And does 15 plus 12 equal 27? Yes, it does. Okay, so we've checked our inequality. So we know that that inequality is correct. But let's see if our direction is correct. How do we check our direction? Now, check direction. And we do that by use original inequality and input 0. So we're going to do the same thing, but we're going to input 0. So we have 0 over negative 3 plus 12 is less than 27. We need to make sure that this is true, because if this is true, that means 0 is a solution, and that means having solutions go towards the 0 would be correct. This way, you're not going to run into 0. This way, we'll go on in negatives forever. So we're checking the direction. So 0 pieces of negative 3 are going to give us, well, 0. 12 is less than 27. Is that correct? Yes. So that means 0 is a solution, meaning our direction is correct, because in this case, the arrow is going to hit 0 at some point. So now that we've done all of that, now the answer checks. Beautiful. Okay, let's do one more, and this one's going to be a bit of a word problem. This is a mathematical problem, like our standard says, a mathematical problem, but let's try a real-world problem. Okay, here we go. You have $50 to buy friends lunch. If each lunch costs $6 and you plan on splitting a $5 dessert, how many friends can you bring? Okay, so here's a real world problem. You have $50. You're going to buy your friends lunch. If each lunch costs $6 and you plan on splitting a $5 dessert, how many friends can come before you run out of money? Okay. First thing we need to find is what we know. Okay, so what is it that we know? We know the dessert. The dessert equals $5. What else do we know? We know the amount of money we have of each lunch, or the amount of money it costs for each lunch, which is $6. We also know the total amount of money we can spend, which is $50. Now there's two things we're going to need. What is it that we do need? We need how many friends we can bring, and we need the inequality sign. Okay, so let's take a look. What can be our inequality sign first? That's what I want to know. We have $50 and we're going to be paying for some stuff. How many people can come? So what is the absolute limit we can spend? Can we spend the $50? Can we spend this amount of money? Yes, we can. Can we spend $50.01? No, we don't have that money. Can we spend $49.99? Yes. And we can also spend $50. So we only have $50. So solution can be 50 or less. That means it can be equal to 50 or less than 50. So we already have our sign. So we're going to input our equation with this sign, less than or equal to. What we're doing must be less than or equal to what? Well, we only have $50. Everything we do has to be less than or equal to $50. Perfect. That sets up our equation correctly. Now we need to find out what we input here. So of the things we know how much money we have. We already put that in. We know what we needed was the sign. We still have the amount of each lunch, the amount for dessert, and the number of friends that we need to somehow include into this. Well, each lunch is going to cost $6, and we don't know how many of these lunches we need yet. That's what we need to measure. So we're going to need to say 6 times the number of friends equals 50. If we were just buying lunches, this would be our inequality. Good. But we still need to include this dessert. And that's just a flat number. It doesn't depend on how many people are coming. So we are going to add that. So now we look at this, $5 plus $6 times the amount of people coming. Oops. Focus. 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 So $5 plus $6 times the amount of friends has to be less than or equal to $50. That's all I have. Okay, then let's go ahead and solve it. First of all, we subtract first. Minus 5, minus 5. Since that's subtracting the same number, we know that the sign is going to be the same. Our new equation is 6n is less than or equal to 45. Next, we divide by what? We divide by a positive number, meaning it's going to stay the same. We're dividing by a positive number. Our new equation is going to be n is less than or equal to 45 divided by 6. Not so sure on my 45 divided by 6 off the top of my head. So over here on the side, I'm just going to say 6 goes into 45. 6 goes into 45 7 times. 7 times 6 is 42. We subtract and get 3. 7 or 6 can't go into 3. So I can put a decimal point, put a 0. 6 goes into 30 5 times. 5 times 6 is 30. We subtract, get 0. Perfect. $7 or 7.5 friends can come. Well, I don't want to cut any of my friends in half, so we need to make sure that we understand what this is a real world problem, meaning you can't bring 7.5 friends. You can bring 7 friends. You do not have enough money to bring your 8th friend. And there we go. So we did one 2-step mathematical inequality and one 2-step real-world inequality. The only difference between what we did last week with equations and what we're doing this week with inequalities is the fact that there is this rule. If you multiply by a negative, you reverse the signs. If you divide by a negative, you reverse the signs. Everything else stays the same. All right, that's it for our work today. On the back here, I'm going to go ahead and write what our homework is going to be. For our guided practice, now pay attention to this because there's a lot of work if you don't pay attention. Your guided practice is going to be lesson 13-1, 13-2, and 13-3 guided practice. Now you may be saying, Mr. Barry, that is a lot of work. That's 3 guided practice worksheets. Of course, I know. Meaning you do not need to complete it all. You just need to go in and make sure you understand this kind of work. So just go try a few from each, don't worry. Now, as far as independent practice, we don't have any today because we have 3 worksheets you can go through and work on. But you do not need to complete this all. Just do what you need to complete. All right, that's everything for today. Hope you have a great day, and I will see you next time.